Hello everyone, welcome you all to AI Ki Pathshala. Today is the fourth session of recursion. In the last three sessions, we have already covered a lot of questions on recursion. We have discussed during the first session, I have discussed about the fundamental concept of recursion and the principle of mathematical induction. Thereafter, we have seen different kinds of questions. And today also, we are going to do the question only. That is the coding part. So I will first explain you the concept behind it, and thereafter I will code it and show you how the code is going to work. And all of you, you should also type along with me and code along with me and see the output. If you guys face any issue, you can interrupt in between and ask questions. Those of you who are watching my recorded session, I request you to please go to the description section of the video and join my Telegram group link. I conduct live sessions for free every day, almost 5 or 6 days in a week. So you can come and enjoy the benefit. Thanks. Now let's get started. I'm going to share you my screen first. Let me share you my screen. So is my screen visible to you guys? Is my audio and video clear to you? Please tell me.
Yes.
Yes.
Fine. So this is session 28. Fine. So let's take this. So first of all, during the last session, what we have discussed, we were doing a question, and the question was, we want to sort out, we want to see whether the given list is sorted or not. Is it fine? So we have done it. I have told you that we will discuss it in two different ways. Our first approach we have already discussed our first approach, so I do not need to discuss it again. And this is the code for the first approach that we have discussed. In that, what actually we have done, I'm just going to give you just a little background so that now when we will discuss the second approach, you will have a much more clarity. So what we have done in that, let's say we have some list 1, 2, 3, 9, 8, 7, like that. There is one list, and I want to see whether my list is sorted or not. For that, what I was using, I was comparing this value, and every time I was making a copy of this list, and I was creating a smaller list. So this is my smaller list, 2, 3, 9, 8, 9, 7. There are 2, 3, sorry. Yes, 2, 3, 9, 8, 7. 8, 7. Thereafter also, every time we are creating a smaller list, copy of the smaller list, 3, 9, 8, 7. Like that, we were creating the smaller list, and it keeps on going. So what was the problem in that? Problem is that, let's say if I will have a list having 1000 or 10,000 items. So in that case, what will happen? I have to make the list copy of 999 items, then 998 items, then 997 items, and this goes on. So this requires huge consumption of my memory space, and it requires huge memory. So this is not this is not a good way of coding. So that's why in the real situation, real time, we do not use this approach. We will use some other approach that we are going to discuss today. We already have discussed these things, this in the last session, so I'm not going to repeat it. So let's see what are the second approach that we can use to solve the same problem. So first of all, I'm going to give you just a brief idea of my second approach that I will be using to solve this question. My second approach is like, let's say I will be having one list. So instead of making, let's say I will be having a list of some number. Fine. 1, 2, 9, 13, 7, 8. Let's say this is a list of 9 number. So instead of making a every time, instead of making a copy of this list, what I want to do, I will use starting index concept. Starting index. So starting index is that, first of all, I will be using, let's say I'm starting from this index. Let's suppose if I will start from this index, this is my index 0, this is my index 1, this is my index 2, 3, 4, and 5. So, and I am comparing it with my next index. Is this thing is sorted or not? Let's suppose. If I get yes, this is sorted, then I will move to the next index. And I will keep on moving till I will get that my result is coming out to be not sorted. Whenever I get this, the result is coming out to be not sorted, I will just return false there. Otherwise, I will go till the end. And at the end, what will happen? Definitely, I will get finally whether my list is sorted or not. So what is my base case here? Important thing is that what is my base case here? So base case is that, let's say if there is list A, so what is the length of the list? Lan A. I can write lan A. My base case is, if let's say my list is empty. First thing is that my list is empty. That is, my list contains no element. Is it fine? My list contains no element. If my list is empty, so by default it is sorted.
Yes.
Are you getting my point? If the list, Ruchi, are you getting my point? Ruchi?
Yes. Yes.
If the list is empty, let's say it doesn't contain any element, so by default it is sorted. I do not need to do anything in it.
No.
And let's say, second thing is that if let's take this list. This is my list that I have written here. And what is the length of this list? What is the length of this list? Let's say this is A, list A. So what is its length?
6.
6.
Yes.
So what is its last index?
8.
Last index. Index.
5.
Not talking about the value at the index. 5. So how I
5.
am getting 5? L is the length of list. So if I do L minus 1, I will get last index. Is this fine? L minus 1, length minus 1 is giving me last index. So if my, now see, you understood this? Now see, if the list is empty, so my starting index, first see this. If my list is empty, this case, my starting index is equal to L. Is it true or not? If the
Yes.
list is empty, my starting index and my length both are equal.
Yes.
Are you getting Mr. Misra, sir?
Yes, yes.
So this is my first base case. If the list is empty, then my starting index and my length of the list is same. Now, my second base case is, let's say, if the length of list is, if the starting index is, if the starting index is L minus 1. What does L minus 1 means? End index. This
Last
index.
index.
Last index, this thing. If I am, if during the time of sorting the index, seeing whether the listing, if I reached at the last index, definitely the list is sorted in that case also. If I reach this point, thereafter I have already checked these things. I have already checked. First, I have checked these two values, whether this is sorted or not. Thereafter, I have checked these two values. Thereafter, I have checked these two. Sorry, these two. Thereafter, I have checked these two. Thereafter, I have checked these two. And finally, I reached at this point. If I have reached at these points, then my starting index will be L minus 1. Na?
Yes.
Let's say if I, let's forget starting. If I reach at this point, so in that means my list is already sorted. Na? Then that means my list is sorted. That's why I've reached here. Otherwise, I would have not reached here.
Yes.
Otherwise, I would have get the false somewhere in between. But if I have reached this point, that means my list is sorted. So there are two base conditions in which my list is already sorted in this case. Because previously I was making a copy. This time I'm not making a copy. I am using the starting index concept, in which I am first starting with my first index, 0 index. Then I am increasing my index position every time by 1. And I'm comparing it with my next index value and seeing whether these two is sorted or not. Thereafter, I am comparing these two. Thereafter, I am comparing these two. Are you getting? I am comparing these two, then these two, then these two, then these two, and then these two. So if I am getting false in true everywhere, then and only I will reach at the last index. Na? Otherwise, I will be, if I would get a false anywhere in between, I would not have reached there at the last index position.
Yes.
So in these two scenarios, my list is already sorted. This scenario and this scenario. So I do not need to do it. So this is my base case. Now let's see with the help of code. Let me explain you how this all works. Now you will understand, because I have explained you the little bit of theory behind it. Now let's code the same thing and let's try to do. So def is sorted better. Let's write this. This is my list. A is the name of my list, let's say, and SI is my starting index. SI refers to starting index. I am passing two parameters here. One is my list and second is my starting parameter. The first, what I would like to calculate, I would like to calculate the length of the list. So this is my len function. Now see, I am writing a base case. What is my base case? If SI is equal to, L minus 1, if SI is equal to L minus 1, this is my first base case. Is it okay with you or not? L minus 1 is my first base case, or SI is equal to L. In both cases, my lists are sorted. If I would meet any one of these two conditions, then my list is already sorted. So what I have to return? I have to return true. Then true in these two conditions. Have you understood till here? Please tell me. Every one of you.
Yes.
Mr. Misra, sir?
Yes, yes.
Fine. So now see. So one thing I have already sorted out. My base condition case I have already sorted. Now see the next thing. What I am doing, I am taking my starting index position and I am calculating it with SI plus 1. What it means? It is checking, I am checking in this list, a list, whatever in starting index I have given, I have not, whatever starting index I have given. So I am checking the value of element at that starting index. Is the value of element at that starting index greater than the value of element just after it? Are you getting? Let's say
Yes.
in this list, if I have 1, 2, 3, 9, 3, 9, 6, 8, 10. Let's say if I have given my starting index this thing, 1. Let's say if I have given my starting index 1. This is 0 and this is 1. So what I'm asking, A of 1. What is the A of 1? What is the A of 1?
2.
2.
What is the A of my starting index is SI is 1. Let's say SI is 1. So SI plus 1, what it will give me?
3.
SI plus 1 is 3.
SI plus 1 is 2.
2. And what is the value of SI plus A2? 3.
3.
3.
So what I am doing, I am comparing here if 2 is greater than 3.
False.
False, I am getting false. 2 is not greater than the 3.
No.
So that means if I am comparing 2 with the 3, between 2 and 3, that means these two are sorted among themselves. 2 and 3. What
Yes.
actually I am doing? I am comparing 2 with the 3. And if 2 is greater than 3, that means definitely 2 and 3 are sorted.
Yes.
So this is what I am doing. Are you clear?
Yeah.
So this is same thing what I'm writing here. So if A of Si is greater than A of Si plus 1, what I said, return true or false?
False.
False. Why false?
Because
I
I
do not, because I have not yet reached at the conclusion, because there are other values present after it that I needs to see, because only the 2 values is sorted, but I have to see the other values which are inside the list, whether that are sorted or not. We do not reach till we have not compared all the values, we cannot reach at the conclusion that my list is sorted. If these 2 values is sorted, that doesn't mean the entire list is sorted. Fine, na? Let's say 1, 2, 3, 9, 7, 15, 26. Let's say these. So if these 2 values are sorted, it doesn't mean that my list is sorted, but I am sure that these two values are sorted. Now for what I need to do, now I have, in the next thing, I have to make a recursive call in such a way that every time my recursion, what my recursion will do, my recursion should compare this value, not in the next time what it should do, it should compare these two values and see is 3 is greater than 9. Fine. So that means this is fine. Now if let's say it is compare 9 with 7, let's say, so now what it will get? It will get, here I get no. If 9 is greater than 7, then definitely my list is not sorted. Let's say instead of this 9, if 5 should have been here, then in that case also fine. Then it would have checked these two. Then it would have checked these two. And finally, when it reached here, then what it will give? It will give me true. Because when it reached here, it has already compared all the values inside it, inside the list. And it has found that now it will reach the base case. And finally, it will return the true value. Hope you understood this.
Yes.
I'm writing this same thing in the form of code. Same thing I have written here. So now in the third, what I am doing, what I shall do, I will make a recursive call. It's a small part sorted. So for that, I am making this call is sorted better. Is sorted better. And here, instead of this, now, in the previous questions, I'm just showing you here what actually I was doing. Here, here we have only one parameter. And my smaller list is a subset of the, is a smaller list, subset of the larger list. Fine, na? My smaller list was a subset of, or is a smaller list than the larger list. But
yes,
here when we are making a recursive call, I am passing the same list. I am not changing the list. I am not copying the list. I am not making a new list. The list is same. Only thing that I am changing the index value at this list. So my next, in the next every iteration, I am changing my starting index to SI plus 1. So my list remains same, so that whatever problem of making lots of copy of the list that we are dealing with in the last approach, that issue will not arise in this case if I will use this thing, because my list is same. Only thing is changing is my starting index. And every time what it is doing, it is comparing whatever starting index it will reach, it will compare it with the next starting index. Fine.
fine.
Now, finally, what I want to return is small part sorted. So this thing, if I simply run this code and let's say take some value, let's say a is equal to, take this value, a is equal to 1, 2, 3, 4, 56, 89, 5, 6, 7. Let's say this. And what is my starting index? SI is equal to, let's take 0. And let's call the function is sorted better what A comma SI. If I simply run this, oh, so what thing I am doing wrong is sorted better A comma SI. This is thing L is equal to len of A. This is fine. If SI is equal to L minus 1 or SI is equal to L, return true. This is fine. If A of SI is greater than A of SI plus 1, return false. Fine. Thereafter is small part sorted in a small part sorted better plus one return. Oh, this is should come this small part sorted. Mistake. Fine. So, Ruchi, are you understanding this? Let me
Yes.
explain you with the help of this thing, so that it will be more clear to you guys. So let me explain you. I am getting a noise from some of you, so maybe it would be better you can mute yourself, and whenever you need to speak, please unmute. So let's take this list: 1, 2, 3, 4, 56, 89, 5, 6, 7. I have to check whether the list is sorted or not. So first of all, see what it is doing. This is my A. What is the length of A? 1, 2, 3, 4, 5, 6, 7, 8. So length of A is 8. See, first it will check if SI is equal to L minus 1 or is SI is equal to L minus 1 or SI is equal to L. Let's say I have given the starting index to be.
Length is 9. Na?
Length is 9. Maybe it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9. So let's take it 9. So let's take the length to be 9. Length is 9. So let's first write here. It would be better if I write here starting index is equal to, let's say, 0. Take it out. So still I am getting false. So let's say my starting index is 0. Take the starting index to be 0. So I am taking the starting index SI is equal to 0. So what it will check? First it will come here and SI is equal to L minus 1 or SI is equal to L. Is any one of these two condition is valid here? Tell me. SI, what is the value of SI here? SI is L minus 1. L minus 1 is 8.
8.
L minus 1 is equal to 8 here. L minus 1 is 8. And what is the
Yes.
value of L? L is 9. So is SI is equal to 8 or SI is equal to 9? Tell me. My first value of SI, I have taken the starting index to be 0. I'm starting
False.
from the 0. It's not valid, it's false. So what it will do? It will jump from here to here.
Yes.
And what it will do? It will check. S of 0 means it is checking. S of 0 means it is checking these and these two values. What is S of 0? S of 0, Si starting index 0, because I have taken Si to be 0. So A of 0 is 1 and A of 0 plus 1 is 1. So this value Si 0 is how much? 1. Si 0 plus 1 is 0 plus 1 is how much? Si is 1. And what is Si 1? 2. This is this 2. Because this is my 0 index, this is my 1 index, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Fine, na? So it is comparing. First, is Si is greater than this two. Si, A of Si is greater than A of Si plus 1. So no. This value 1 is greater than 2.
False.
False. So what it will, what happens? It will move to the next thing. This where, what is here happening? Here is a recursion call, is sorted better. So the control will move from here to, the control will move from this point to this point, because this is a function call, is sorted better, same thing, function call is there. And now this time what I am doing, what it is doing, the list is same list A. Only the thing is that this time this starting index is changing. By how much? By plus 1 value. So what is my starting index now? This time 1. 1 is my starting index, because this has changed. Please, you guys keep on answering me so that I can understand you are getting my point. Otherwise, how I can understand you are understanding or not. Fine. So, Ruchi,
Yes.
are you understanding this?
Yes.
So, this is my Si plus 1. So, starting index now is 1. Now, control is coming here. Again, it is checking. Again, the condition is false. Again, it is coming here. Again, this is false. Again, this is coming here.
Okay.
Again, it is coming here. Again, my list is same. This time, what is happening? Starting index is getting changed.
Change.
To how
2
much?
plus
After 1, it becomes 2, because 1
2.
plus 1 get added here.
Okay.
So it becomes 2.
Yeah.
Again, here is a function call. Again, it is coming here. Okay, again, starting index again, it is coming here. It is becoming false. Again, it is coming. Again, it is coming. And again, starting index get changed here from plus 1. So it becomes 3. 0, 1, 2, 3. Fine.
Fine.
Now, this time it is, let's see this time what is happening. 1 is greater than 2. Is 1 greater than 2? I am getting false. Fine. 2 greater
Yes.
than 3. I am getting false.
What?
3 greater than 4. I am getting false. But here, what it will check? 4 greater than 56. Is 4 greater than 56? Yes. False. I am getting false.
False.
Here again we will get false. Here again we will get false. Now here again, if it check 89, greater than 56, when this comes 89 greater than 56, what I will get? True.
True.
So when I will get true, my this condition will get satisfied.
Yes.
Sorry, not this condition. Sorry, not this condition. This condition will get satisfied. This condition will satisfy.
Yes.
So what it returns me? False.
True.
That means my list is not sorted. False means my list is not sorted. Do you got it?
Yes.
Or you want more clarity on this? You can take any other example and let's check with the help of that example. If you want, I can give you one more example. Let's take this example. 100, 200, 150, 500, 90. So what is the length here?
5.
5. Let's take, this is my A. Let's take a starting index as 0. Fine. I am taking my
Fine.
starting index to be 0. So say here, what is the value of SI? Is SI, what is the value of L minus 1? First, right, what is the value of L minus 1? 4. Is SI 0 is equal to 4? No. Or SI is equal to L? No. So I am getting false here. I am getting false here. So it will return to this point. Now, what it will do? It will check these two values, SI0 and SI1. This is greater than 100 is greater than 200. It is getting false. Again, it will come here. Again, this is a function call. A will remain same. Now this index will increase. Control will come here. Again, the same process. Again, it will check. This will become false. This also will become false. Now see. When it will come here, it will check. Is 200 greater than 150? What I will get? During the function recursive call of the function, it will check. So what I will get is 200 greater than, if 200 greater than 150, what I will get? True or false? Tell me, Ruchi. True or false?
True.
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 So this condition will become true and it will go inside it. You understood?
Yes.
Now let's take another case. Let's take 20, 30, 40, 50. This time what will happen? And let L will be 4. L minus 1 is 3. And let's
3.
take starting index 0. I'm starting from 0 index. This
0.
is 0. This is 1. This is 2. This is 3. So what will happen in this case? It will check this thing. This will become false. Initially, this will become false. So it will move to this step. This will become false. So it will come here. So this will remain same. Index will increase. Again, the control will shift here. Again, I have compared these two values. these two comparisons done. Now, when the function has called, now it is comparing. Now my starting index is what? During this my recursive call, this time it is starting from this index and comparing the value of this index with the next index. So my starting index is 1, and it is coming here. This is becoming false, it is coming here, and this time what it is doing? Comparing 30 and 40. So fine, this is becoming false, again this is coming here. Now this time what will happen? This is also fine. Now my starting index will become 2, this. So now again recursive call. So this time what will happen? Again this condition will not meet, it will come here, and now it is comparing this with this. Again I am getting false, so it is coming here. This time what will be the my starting index will get increased. So what is my new starting index? 3. Now see, SI is starting index is 3, and L minus 1, as we have already done it, is also 3. So this condition will become true here. It's meet this condition. SI is equal to L minus 1. Now SI is equal to L minus 1. So this is true. So what it will return? True. That means this list is fine. Fine or not?
Yes.
Once again.
What I have told you that I have taken this list, and it
No, from here. Yeah, from the last one. I mean, the is small part sorted is small part better. A
okay.
comma SI plus.
So see, what I'm doing, when it has first compared these two, then it has compared these two, then it has compared these two. Fine. So
Yes.
at the end, the starting index, this starting index value is increasing every time by 1. So initially it was 0, then it has increased to 1, then it has increased to 2, and finally it has increased to 3. So when my starting index become 3, SI become 3, and we have already what I have written a condition here, SI is equal to L minus 1, and my L minus 1 is how much? Here the length is 4, so L minus 1 is 3.
3.
So L minus 1 is 3 here. Now my starting index is equal to L minus 3. Starting index is equal to L minus 1.
And
so
what is A here?
A is this, A is my list, na? This list is A is my list. So this condition is becoming true.
Yes.
So if this condition will become true, it will go inside it. And what it is returning? It is returning true. True means?
All are sorted.
Means my list are sorted. All are not, my list is sorted.
Yes.
So are you understood this? I have taken all the scenarios. One scenario is left. That let me take it. That scenario also. Let's take A is equal to empty list. And let's take SI is equal to 0. And now run this and see. I am getting true. I have told you in the beginning, Here what is happening? My SI and my LAN. Because if I run LAN A, let's say LAN A, what I will get? LAN A, what I will get? 0.
0.
And what is my starting index? It is also 0.
0.
So SI is equal to L. So this condition is meeting and I am getting true. Because
Already sorted.
if the list is empty, I have already explained you at the beginning, if the list is empty, it is already sorted. And if I will reach at the last index, that is L minus 1, in that case also my list is sorted. Fine. So we are done with this question. So now let's move to the next question. Let me first give you what is my next question. Then I am going to explain you it. If you want to have some water, you can have. If you want 2-minute break, I can give you. So do you want break of 2 minutes? If you require break, I can give you. Maybe water break, toilet break, whatever break. So let's take break for 2-3 minutes. Thereafter, we will going to start.
Okay.
So let's start. Abhi, what we are going to discuss in this question, let's first understand what is my question. So the question is like, let's say I have one list and this is my, let's say, one list. And in this list, there is one element called X, which is occurring 3 times at different indexes. So what I have to find? I have to find the index position of the first occurrence of X. First occurrence of X. Occurrence of X. Do you got my question? Let's take, this is a list. 3, 5, 7, 9, 7, 11, 7. So see, 7 is coming 3 times at this position, at this position, and at this position. So let's say 1, 2, 3, 4, 5, 6, 7. So I have to find out the index position at which the 7 has occurred for the first time. So I have to find out this index. This is my question. Hope you got my question.
Yes.
Sir, have you got my question?
Once again.
This is my index. Sorry, this is my list. So what is, let's take, this is my list. 3, 4, 5, 7, 5, 11, 5, 9. Let's say this is my list. Fine.
Okay.
So in this list, this 5 is occurring 3 times, or as many number of times as it is occurring. Here I have taken 5 is occurring 3 times. So I have to find the index of the 5 at which 5 is occurring for the first time. This is the first time that 5 is occurring.
Yeah.
This is the second time 5 is occurring.
Yes.
And this is the third time 5 is occurring. So I have to find at the index of this position at which 5 is occurring for the first time. Are you getting my point? Let's say if
Yes.
0 is this index, this is 2, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So at these indexes, 5 is occurring at this index, and this index. But I have to find this index only. Index at which 5 is occurring for the first time. Now, question is clear?
Yes.
Yes.
If question is clear, so let's understand a little bit of concept here, okay, how we are going to solve this question. So we are going to use whatever approach we have used in my last question, exactly same approach I have to use in this questions. Or this question can also be done by the two approaches which we have discussed in the last question. Two approaches which we have discussed in the last question. So you already know that my second approach was a better approach to deal with this type of question. But what I am telling you, I am also explaining you here also, and after the class also, whenever you will practice, you practice by both the approach. Actually, in the real scenario, you have to solve this question by the second approach, but for the sake of your practice and understanding, you should practice by both the approach initially. And therefore, I am going to explain you this question also by both the approaches. Now, first, tell me one thing. Let's suppose this is my list, any list. If I have to calculate the first occurrence of X, so one thing that, yes. So in the last, what in the first approach that we are using in the last question, what we are doing, we are making a copy of the list. We are making a smaller list every time. Smaller of this list, then again smaller list, then this one element is less than, and we are making copies, and finally at the end we are able to understand whether my list is sorted or not. So this approach I will use to find the index position of this first occurrence of X in this list. So I will tell you two more things. Let's say, first let's take this thing. Let me write you the question first. Okay, let me tell you what is my base case here. So tell me let me first tell you the base case. What is my base case here? So my base case in this position should be, let's say, if my list is empty, you understand this. If let's say my list is empty, this is my empty list. If my list is empty, then it should return -1. What does this -1 signifies? It signifies it signifies X is not present anywhere, not present anywhere. Do you get it? Let's say if my list is empty. So if my list is empty, it should return -1. And this -1 signifies that X is not present anywhere. And let's say if there is list, and let's say 3, 4, 5, 6, 9. And I am asking you to tell me whether what is the first occurrence of 15 in this list. So this 15 is not present inside this list. Are you getting? This 15 is not present inside this. In this case, what it should return? It will return you -1. -1 simply says that whatever item I am asking it to give the index position, first occurrence of that item, the index position of the first occurrence of that item is not present. So this is my base case here. We have to keep this thing in mind. Rest of thing is almost same. Only the difference is in the base case. So let's write a program. So let me first write it and keep understanding as I write the program. Def, this is first index dx, first index, and I have to supply the list, and thereafter whatever value I want to see the index, first occurrence of the index position of that value, I have to pass that thing. So L is equal to len of A. If L is equal to 0, let's say if L is equal to 0, so what it should return? Ruchi, if L is equal to 0, what it should return? If L is equal to 0, what it should return?
It should return true.
True. It should return -1 because L means 0 means the list is empty.
Okay.
L is equal to 0 means list is empty. That's why the length is 0. And if my list is empty, then it should return -1. And -1 signifies what? That value which we are searching in the list is not present inside this list. This signifies -1.
Yes.
So this is my this is my base case. If now second thing, if A of 0 is equal to X, let's say my first index position value is the X. In that case, what it should return? 0.
0.
If the first value in the list I am checking, if that value itself is my X, then it should return 0. Fine.
Yeah.
Now, after that, let's say if this becomes false, then what is my then I will create a smaller list. Smaller list just in the, as I have done in the last question. What should be my smaller list? Tell me. I will slice the smaller list from index 1 till the end of the index. Fine, na?
Yeah.
This is my list. 3, 5, 9, 7, 11, 7, 12. Let's say this is 9. So this is my first index. If this is not X, and let's say I have to find this 7 is my X. Let's suppose this 7 is my X. This 7 is my X. I have to find this index position. So what I will check at the 0th index. This is my 0. This is not present. Then it will create a smaller list. What is my smaller list? This is my smaller list. 5, 9, 7, 11, 7, 12. Are you getting?
Yes.
So a smaller list is starting at first index. This is my 0 index. This is my first index. So it is starting and it will go till end, till here. So my smaller list gets created. Now, after that, what it will, I have to calculate the smaller list output. The smaller list output. What is my smaller list output? First index, I have to do a recursion here, and in this function first index, what is the new value of my list? A smaller list will be my new value of list, because now I'm not seeing in this list. I want to see in this list. So smaller list, comma x. Fine. If smaller list output is equal to -1, then what I shall return -1. Otherwise else return smaller list output +1, output +1. So let's run this. Invalid syntax in line 14. So where is the line 14? Okay. ELC. So now it gets run. Now let's check. Give me any value of x, any value of list. Ruchi, please give me. You first. You give me any value of list here.
5,
5,
7,
7,
10,
10,
9,
9,
37,
37,
2.
2. But you have not repeated any value, which I need to find the first index of that value.
Okay, 10.
Okay, 10. So what is the value of x here? 10.
Yes.
So first index, and I shall pass what? A comma 10.
10.
If I shall run this, I am getting 2. See, 0, 1, 2 is my index. So let's understand it once again. I'm going to explain you this code with the help of this example. First, I have defined one function here, first index, and what I have passed, this is my list, and this is the value x whose index I want to find. First occurrence of whose index I want to find. So if L is equal to 0, return -1. This is clear. If my list is empty, that means
Yes.
Q is not present. So I shall return -1. This is also clear. If A0 is equal to X, then return 0, first index. But let's say if this is, in this case, this is false, and this is false, this condition is false, and this condition is also false. So it will come here. Now, a smaller list is, what is my smaller list here? 7, 10,
7,
9,
10, 9, 30,
37 to 10. This is my smaller
10.
list.
Yes.
My smaller list.
Yes.
Now, what is the smaller list output? Simply, I have called the function again. I have called this function again. And
Yeah.
in that function, instead of this A, I have passed this smaller list. And this X will remain the same.
Yeah.
So again, it will check if L is equal to 0. No.
No.
0. So again, what will happen? Again, it will come here and it will again make another smaller list. What that smaller list will be? 10, 9,
9, 37
to
to
10.
10.
Now, this time, again it will go here. Function call, control
Yeah.
comes here. It is checking if L is equal to 0. No. Now, this time, when it will check, now my new value of A is this. If A of 0 is equal to 10. So yes, it is true. My A of 0 is true. A of 0 is equal to X. So what it should return? 0. Fine. Now,
Yeah.
now, one very important thing that you have to understand in this, that's why I was explaining you. If it will return A of 0 is equal to 0. Let's understand this. What was my first list? My first list was 5, 7, 10, 9, 37, 2, 10. This was my first list. Mr. Misra, sir,
Yes.
please be careful here what I am going to explain you. So it has, first I have told you that here it has met this condition and it should return 0. So this function should, what this function should return? 0. What is the return of this thing? 0.
0.
See, first let me explain you this. So my original list was this: 5, 7, 10, 9, 37, 2, 10. So I have checked in this. I do not get anything. So I have make a smaller list from this list. This is my smaller list by using these values. Thereafter, I made another smaller list. And finally here, I got A0 is equal to my X, which is 10. So this has returned, what index value it has returned? Returned 0. So this has returned 0 to whom? To the function which came before it, this thing. So it has returned 0. Now, what is the, but let's see, these are different lists. And this list, this should return 1 to this and this should return 2 to this. Why this is? Because it has returned 0, but one when I was creating this list, I have already sorted this list by one index. Have you got my point? Do you get my point? When I created this list has already sorted the length. I have already sorted the length of this list by 1, and I have already sorted the length of this list by 1. 1 I have already sorted, 1 I have already sorted. So when this is returning the index of 0, let's say return 0, when it is returning this 0, return 0, and it is returning this 0 to here. So now this is returning 1 to here, and this is finally returning 2 to here. So finally I am getting 2 as my index, because every time I am shortening my list by -1. So this has returned 0, this has returned 1, this has returned 2, and finally I am getting 2 as my index position, first index position. Do you got this?
Yes.
Mr. Sir, do you got this? Mr. Sir?
Once again,
Okay. So will you please tell me where you are facing difficulty, at which part we are you didn't understood?
the
So
last part.
last part. Okay. Let me clear it out. See, my original list was 5, 7, 10, 9, 37, 2, and this 10. Is this fine?
Yes. Yes.
See, this was my original list. Okay. And what is the value of x? My x is equal to 10. Got it?
Yes.
So, and what is my length here? 1, 2, 3, 4, 5, 6, 7.
7.
So it is telling if L is equal to 0, true or false?
False.
A0 is x, false. It is coming here. Since these two conditions false, so it is making a smaller list from this list. What this A1 of 1 to this, you already know the slicing operation. So what is my new list?
7, 10.
10, 9, 37, 2, 10.
Hmm.
This is my new list.
Yes.
For the new list, now when I am calling the function again, this function here, so what is the value of A now? This smaller list, this thing,
Yeah.
this is the value of A now. Is what is the value of L here?
6.
And what is A of 0 here? 7.
Yeah. 7.
So both the condition is not satisfied, false. So it
Yes, false.
come here, and it will again, what it will do? It will again create a smaller list. What is my
Yeah.
smaller list?
10, 9, 37.
9, 37,
2, 10.
10. Now it will come again here, and this
Yes.
time it will again call the function. Now this time this value smaller list is this list.
Yeah.
This list, it will pass this list and x. So my control will come again here.
Hmm.
It is checking first this condition. L is equal to 0. No, my L is equal to what here?
Value 6. Sorry, 5.
5. So this condition become false.
False.
Fine. Now let's check this condition. Let's check this condition. A of 0. What is my A of 0 here?
F0 is 10.
10. And what is my X?
X is 10.
So A of 0 is equal to X.
Yes.
So what it should return?
0.
True. Yes, it will give me so. So what it should return? 0. So what this recursive function return? What this recursive function return? 0. 0 to whom? To this. And now this list has, this list is one element, this list is one element shorter than this. This list is one element shorter than this. The length, see, my original list is getting shorter, smaller and smaller by 1 unit. Na? Here 5 gets removed, then here how much value get removed? This 2 get removed. 2 values get removed here. So this has returned 0, this has returned 1, and this has returned 2. So that's why I am getting 2 as my final output. Because the original list is getting sorted, na? Do you get my point or not?
Yes.
What is my length here? 7. What is my
7.
length? 6. What is my
6.
length here? 5.
5.
So 7, 5, 6. So actually, I am calculating in the original list, the index value. The index value in my original list is 0. But what we have to see, we have to calculate the index value at my at this original list, na?
Original list.
So index value at the sorted list is 0. Let's say if this is 0, you can understand by this way. Let's say if this is 0, if this is 0, this is 1, this is 2. So this list is returning what? 0 to the list before it. It is returning 0. But this list is returning 1 to this list. And this list is returning 2. So finally, what I am getting? 2.
Yes.
Do you got Ruchi? Do you got this point?
Which one? Yes.
So fine. So so I suppose there is no doubt here. Shall we move to the next part of this question? So next part of this question is same question is same, everything is same. Only I have to approach this second, I have to use this second approach in the next part of this question. So what is my what was my second approach? Second approach is that I will not make a new list. Every time I will not make a copy of a new list, but in the original list, I will simply change the index position and I will calculate it. So let's see how I am doing this. Def first index, let's say B, write the name of this, A comma X comma, this is my starting index. So let's first write if L is equal to if L is equal to len of A, and if my starting index is equal to 1. Now there is a question. Return -1. Why I am starting with the first index? Why I am starting with the first index here? Let's see. First understand why I am starting with the first index in this case. So let's first take this thing. Let's take this list. What I am first I am passing this list, then after whatever value whose index I want to know first occurrence of the index, and this is my starting index from the position where I am starting my index. So why I am not considering this index? Why I am not considering my 0th index? Why I am starting from this index? Any one of you, will you please able to think over it and give me an answer? Any one of you? I'm giving.
Because we don't want to copy the new list again, so we have started from index number 1.
We don't want to copy. Yes, definitely we don't want to copy. Thus, then what is the use of why we are not starting from the first index? Why we are? What is the base case here? Let's first understand what is the base case here. What is my base case here? Any idea? So instead of writing this L here, I was writing 1 here. And I was confused why I was writing here and I am not getting the output. So see how this is working. It's fine now. So at like after you work for 12, 13, 14 hours, and this is 12 a.m. in the morning, 12 a.m. next day. So this happens. Let me explain you and finish this out. Let me explain you this thing. Okay. See what I am doing here. See what I'm doing. I have taken this function. First index, I have defined this function. I have defined 3 things inside this. This is my first parameter, A. This is my second parameter, and this is my third parameter. Are you getting this thing? This is
Yes.
the starting index. This is my list. This is my list. This is the value of X whose index I want to find, and this is my starting index. Now, what I am checking here, I am checking the length of A. So let's take this problem, maybe this problem. What is the length? 1, 2, 3, 4, 5, 6, 3, 9. So 9 is my length. let's say. So L is my 9. I am checking if SI is equal to L, and I am passing my starting index as 0. 0 is my starting index. SI is equal to 0. I am taking SI is equal to 0. SI is equal to L. Is it true or false?
False.
False. So I will jump here. Now I am checking if A of SI is equal to X. Is A of SI is equal to X? What
No.
A of SI? A of 0?
Huh.
A of 0 is not X.
No.
What is my X here? 6.
6.
So this is also false. So I am coming here. Now this time see, as in my last problem, I was making a copy of the list, smaller list. This time I am not making a copy. Simply what I am doing, I am taking the same list, my original list. I am taking the same value, which just I am increasing the index value to +1. So what will happen? This 1, 2, 3, 4, 5, 6, and so on, whatever is the value. What it will do? First, it has checked at the first index. Now what it will go? As I get increased to 1, so my first index value is 1. My first index will become 1. SI, now after the index get changed, what is my index value? 1. SI is equal to 1. So now it will again come SI is equal to L. No, this is false. Again, this is false. Again, it will, my index will change to +2, then 3, then 4, then 5, and it will keep on increasing. In every recursion call, in every function call, what is happening? Only my index position is getting changed. Rest everything is same. My list is same. Value whose index I would like to see is same. Only my index position is changing, is increasing. And at every index, I'm checking is the value is equal to X or not, and is SI is equal to L or not. This SI is not equal to L. This may be possible. SI, if I reach at the end of the list, then in that case my SI will become L. SI will become L, will become L if I reach at the end of the.
Yeah.
So it get increased, and what when it will reach 6, when it will reach this point, what will happen? A 1, 2, 3, 4, 5, 6, A7, A5 is will become 6. So it will return SI, starting index. And I will get this result, and I am returning this thing. Is this thing clear to you or not?
Yes.
Mr. Misra sir, if you have not understood, please raise question, or please tell me. I can explain you twice, thrice, 6 times. No issue. Misra sir? Misra sir? I suppose Misra sir,
Yes, yes, yes.
have you understood this thing or not?
Yes.
Can you explain me if you have understood this? If you have not understood even a little bit, please tell me. I can explain you once again. I don't have any issue. Please tell me, sir. Either you explain me or I am going to explain you. Choice is yours.
You explain.
Fine. I am going to explain you once again. See, sir, what is happening here? First of all, tell me, have you understood this code or not?
Understood. Yeah.
Okay, you got the code. So tell me any list as per your choice and repeat the value maybe 2 or 3 times, whatever you want in that, and I will run it and I will explain you with the help of same list, and not take a bigger list, take some smaller list. Tell me the value that you want
3,
to.
5, 7, 10, 7.
3, 5,
7, 10, 7.
7, 10, 7. Fine. So this is my list. What is this? A. Fine. And what is the length of this list?
5.
5. What is my starting index that you
3,
want to take? 0.
0.
Let's take 0. So these things, fine. I am not going to take the output. I am just calculating the output by explaining you. First thing, when it will go to this function, it will check L is equal to, what is my L? 5.
5.
SI is if SI is equal to S, tell me,
No. No.
this condition will become
False.
false. So what happened? It will come here.
Yes.
What it will check? A of SI.
Yeah.
What is my SI? 0.
0.
A of 0 is what?
3.
A of 0 is 3. So is 3 is equal to X? And
No.
what is my X here? What is my X here? Please tell me.
X is 7.
7. So A of 0 is A of 0 X? No.
No.
This condition will again become false.
False.
Fine. Now, it will come here.
Yes.
A smaller list output, this is the variable. And
Yes.
inside this, what is? This is a function call, first index B. See, first index B, first index. This is a function call. Fine. Inside, this is a recursive call of the function. Inside this, what is my A? A is my list. This
Yes.
list. This is my A. What is
Yes.
this thing?
X7.
And what is my this thing?
0 plus 1. 5.
Correct. This is my 0 plus 1. So what is my this value? 1.
1.
With these values, my control will come back here.
Yes.
Now this time, what is my SI? SI is equal to L. This will again become false. No. Fine.
Yes.
This will become A of SI. What is my SI? 1.
1.
What is A of 1? 5.
5.
Is 5 is equal to 7? No.
No.
False. What will happen?
False.
Again, the control will come here.
Yes.
Again, this time what? Again, what will these two will remain same. Only the index position will change. Starting index will change. This time, what will be in the starting index? 2.
2.
Here 0, 1. Now this is my starting index u. With this starting index and A and X, my control will come here. Are you getting? Sir?
Yes.
Now, again, this condition will become false. SI is not equal to my length. This condition will become false. This condition will become false.
Yes.
But this time see, what is my A of SI? A of 2. What is my A of 2? What is my A of 2? See
A
here.
of 2 is 7.
7. So my a of 2 is equal to x. And what is my x?
7.
That means a of 2 is equal to x. A of
Yes.
2 is equal to x.
Yes.
So now this time my this condition will become true.
True.
If this condition will become true, what it should return? Si.
Yes.
And what is my Si?
0.
Si
2.
2. Because my Si has increased, na? This is my new Si. Every
Yeah.
time I'm increasing my Si by +1.
Mm.
So what this should return me? 2.
2.
That is my answer. So now do you understood this?
Yes.
Now can you explain me? Are you able to explain me now? Hello, sir.
Yes.
So then you have understood it. If you are able to explain it, then that means you have understood it. If someone is not able to understood it, that means maybe he has understood it, but not 100%. But now if you are telling that you can explain, that means you have understood it 100%. My only purpose is to make the things clear to you 100%.
Yes.
So let's run this thing and check. Is I have okay. Let's take some other thing. Tell me some list, sir. Tell me one list. Tell me any list.
3, 5, 7,
7,
10, 7.
10, 7. And what is my value? X is equal to 7.
Yes.
The starting index, let's take 0. And this is my function. I'm getting 2 here. I'm getting this correct output 2. Do you understood this?
Yes.
Fine. Actually, I want to explain you one question more, but today I suppose is not possible because it's already 12:30. So maybe we can do it sometime later. And so guys, anyone who are watching my recorded session, I request you to subscribe my channel and come for the live session. It's completely free of cost. I'm not charging anything, so take the benefit. So here, let's stop the